So this is pretty much what I'm going to talk about today, a little bit about Monash e-research, our HPC infrastructure, and a little bit about Massive 3, which is our latest high-performance computing. A bit of marketing slide. We have about 63 million CPU core hours that spans across different clusters in Monash, and it has been, we also has been the largest users for the national funded supercomputing, which is based in NCI in Canberra. We have lots of instruments integrations. Monash is big with the life sciences and also instruments integrations that go across Australia as well. We are not that big, but we do have a lot of requests from the researchers, and we are trying to accommodate their CPU requests, GPU requests, especially lately, a lot of machine learning users asking for GPU. And we are 5 times over subscription at the moment. The queue is always busy, a lot of jobs, users. And we not just have HPC performance, high performance computing services, we also have cloud services that we provide, and at the moment we have like 10 plus petabytes of resource storage available with different kind of formats. It could be block storage, it could be bar system. In Monash, we always like to use the analogy with using the microscope by saying that we, from capturing to analysis to actually provide the visualization techniques to the researchers. And finally, we actually help the researchers to manage the data. The HPC infrastructure that we have in Monash, we would group it to 3. So we got the campus cluster, we got Massive, which is the leadership in the characterizations, and lots of instruments integration actually happening in this space. And we do also have the access to the national computational infrastructure, and we have been the biggest users for that infrastructures. And depends on the request that we're getting, we assign the CPU or projects to different requests. Massive itself, we get funding by partners and nationally as well. And we have universities such as University of Wollongong, Australian Synchrotron, and the CSIRO, which is the national facility for researchers, and partners in, not sure if it's relevant to you guys, ARC, the Australian Research Council, and the partners in brain science and advanced molecular imaging. So as of today, we actually have 170 active projects and 2,000 users account, and lots of institutions that collaborate with Massive. One of the big things that we have is the instrument integrations from IMBR to cryo-EM, and lately we have a lot of latest light sheet instruments as well. And just to emphasize, those researchers are very new to HPC, hence we actually need to provide some tools for them to visualize their, to run their software. And later on, I'm going to give a live demo on the visualization part. Big data. So yes, everyone is struggling with this. The microscope that we installed today is getting bigger and bigger, and the data they generate from them are getting better. finer, and the qualities are way, way, way better than in the past. So this is more like a planning for me. So we looking at what instruments integrations that we have today and accommodate the one that we want to integrate to massive. And you can tell that the jump is way higher than what we can accommodate today, so 2018. M1, M2, they are the old classes, and recently we have just decommissioned M1, the IBM-based clusters, and M3, which is just going to production last year, has been more medical and health sciences focused. As you can see, in the past, the medical and health sciences is only like 10%, and it went up to like 42%. This is based on the field research codes that we're getting from different projects. We do have campus cluster, so teachers, researchers, obviously they come to us and say, I want to teach students how to use HPC. And we have that free for all, so they don't have to pay for anything. So they came to us and they will be like, I need to teach this, and we actually help them to develop the course content as well. Some of my colleagues actually sit in a class to help out the students to actually use the supercomputers. Using the job scheduler is the biggest challenge. Let's repeat it. I want to talk a little bit about CBL and instrument integrations. So we have this remote desktop set up for each other, anyone that can use, actually anyone that use Massive. So it's called Strudo, and some of you might already think like, I can just spin up an instance and use S2Go. For this instance, this is just running BNC in the background, and it's actually scheduled a job to Slum. I can quickly show you later how it works. So this has been very useful for lots of researchers in Australia, and recently Cambridge has just deployed the same instance in their infrastructures as well. Yes, live demo. So I hope it works. So if you go to desktop.massive.org.au, so if you have a project, you can log in using your AAF, which is Australia Federated Credential. For this instance, you can choose which system you want to access. Because the identity is federated, anyone that has the AAF login with the project can just use this Strudo desktop from anywhere in the world, pretty much, if the internet is allowed. For this, in this part, you can choose if you want to run a standard desktop or a large desktop. For this one, how we configure it is we use Slum job scheduler to assign GPU for each of these instances. So you can choose how many nodes do you want to use, the processors per node, the memory, how long do you want to use it, and the project that you want to assign it to. So for this instance, I already spin up a desktop session. So I'm just going to resume my desktop that I spin up before. So for any users that have a project, you can see your last file system, your home directory, and everything. In the file browser. It's a bit slow. And we have a list of software that is available by the icons. This is pretty much just using modules and to actually run the software. So I'm just going to quickly run an applications. And this is how any of the neuroscientists can actually visualize their images on the desktop sessions. And how it works is so if I do a show job, so this actually telling me that I actually have a Slurm jobs that running on these nodes. And if the time runs out, you can just use any Slurm commands that you want to extend the desktop session. This has been very helpful with the researchers actually giving a presentation, and that I can actually visualize all the images that store in a raster file system. Let's go back to this. Ragmon. So we do have a research cloud. It's both private and public. So we're running Cumulus and Monash Rocky Ethernet on for the networking, and the backend this safe walk. The project is actually run by Nectar, which is the project that has probably 5 or 6 affiliated universities across the country. And as a researchers, you can actually spin up the instance on the research cloud if you have a project with them. A little bit about Massive Tree. So this is the latest massive supercomputers. So it's the 3rd generation, as I say. That's why it's called M3. So it's a bit different from the traditional HPC. Reason being, the whole HPC is actually on the cloud. So this has been quite successful, to be honest. It was a long journey to get there. We do a lot of tuning and stuff. I'll show you a few slides, just one slide after this. We do pass through Monash CX3 and CX4. As James said before, Monash has been very painful to work with. Yeah, we do see a lot of issue working on that with raster. We pass through our GPUs as well. We got K1, K80, P100, and recently we have V100s on the computes. It's very high demand for visualization jobs, so people always want to get the latest and greatest. And so when they come to us, they say, hey, I want V100, and we always ask them, why do you need V100? And because they're quite expensive to run. So at the moment, for the visualization jobs, we tend to point them to the K80. So why do we run HPC on the cloud? There's a lot of reasons for it. One of the things is the segregation. So a lot of you might say, why can't you just use the job scheduler to carve up your jobs? But when it comes to security, a lot of researchers actually said, no, I don't want to share any notes with anyone. So we tend to say, okay, in that case, we will just carve up the resources, the actual hardware resources. And for example, we got boxes with 4 K80, and we can actually have 4 instances for each of the projects. RDMA over Ethernet is the networking, as I said before. And we are actually in the process of upgrading V1 to V2. A few things to be changed in the networks layer. For example, we can't actually use Connect X3 in that space, so we have to upgrade all our fleet to Connect X4. Lots of software in the Singularity container. If you are a Singularity user, yes, we love Singularity, and we have been big contributors to Singularity developments as well. Not me personally, my colleagues in HPC team. And recently we upgraded our Slurm to version 17. There's 2 bugs that actually annoy me for the entire few months. If you looked up the ScapeND, sorry about the typo, ScapeND bug report 2748. So this is about Lustre client nodes crashes all the time when the K-mem they enforce the kernel memory C group on the instances, on the job, sorry. And Intel was really kind, and they actually released a patch for 2.7. So I managed to reduce the crashes on the nodes, but however, it didn't actually fix the kernel memory constraint issues. So in order to do that, Slurm actually say just upgrade it to version 17. And to upgrade from version 15 to 17, it was painful as well. Lots of database processing and migrations, and it went well at the end of the day. And we had to schedule a full maintenance to do that just because it was a risky process. A little bit about the virtual HPC that I was mentioned. So the public network and the internal network in this instance are actually managed by Neutron from OpenStack. And the data network is the pass-through CX4 or CX3 network that I mentioned before. So that actually connected directly to the Lustre file system because we can't virtualize yet Lustre. So this is a bit hard to see, my apologies for that. This is the HPL result that we run to compare the performance on the bare metal and the GES, which is the VM. It's about 40 runs. We are seeing 1.6 teraflops for this instance, and the software actually builds in Singularity container, so that to make sure that it's portable across the bare metal and the instances. And yeah, we are actually quite happy, but as you can see, there's a few of the bare metals that are underperforming, and we are yet to find out why is that. So some of these instances are actually has been tuned just to make sure that it has the best, the peak performance. The things that we have done, for example, the NUMA topology, lots of CPU tuning, and the transparent hue pages setting as well. So if you look at our commands to spin up an instance, it was really, really long. I was thinking to put the commands here, but it just ran out of space. N3 has been upgraded this year. So we have bought some Skylake CPU nodes and 60 NVIDIA V100 GPUs and a couple of DGX one. If you have seen DGX before, it looks it actually looks kind of ugly to me. It doesn't match the whole data center, so it is for display purpose. But DGX one has been really good for our workflow in the cryo-EM, for example, running the software like rely on. The file system is not big to begin with, but after the upgrade, we have about 3 petabyte usable, and we are running the 100 gig Ethernet Monash Spectrum networking switches. So it was my decision to go vertical instead of horizontal in this instance. We have 6 only object storage server. After the upgrade, we bought the few like Dell MD3060E expansion module, and this is instead of buying the 4 terabytes disk, we're actually getting the 8 terabytes, so that way we can actually increase the capacity as well. I'm yet to test out the performance because in a future upgrade or expansion, we'll probably go horizontal instead of vertical just to reduce the load. And in Monash, what don't we have? So you guys probably have a lot of different file systems in your institutes as well. So we have JFS that serve as an NFS server, Glasser FS, IBM GPFS, SFFS, and Lasser FS. SFFS has just come to the pictures this year, and we're still doing a lot of benchmark. At this stage, we are not quite ready to be used in production, but we have seen a lot of requests for something like SFFS, just so that it can be integrated to the cloud environment and the HPC environment easier. So we have recently decommissioned M1 and M2. They both have M1 and going to decommission M2 very soon. They both have GPFS. And for M3, we have decided to use Lasser instead of GPFS for the reason being that Lasser has a lot more community support, and they have the single driver for OpenStack. And as you know, the maintenance and cost and efforts for GPFS are quite high as well. It has been great. The transition, we haven't actually got much complaints or anything. They say that, why did you change the file system? And a couple of reasons that we choose Lasser as well is because we want to make sure that in the future we can actually mount Lassers on our OpenStack environment, whereby the researchers can spin out any instances they want. They can run their own image, build their Singularity container, and actually port the image to HPC and run their software from there. Lastly, so we actually use Intel Manager for Lasser. I don't think any of you maybe not quite across this yet. We're using IML in a managed mode, and we use it for monitoring as well. One of the good things about IML is it actually provides the job status as well. If you click into each of the OST, as you can see here, the balance of the OST is not quite there yet, so we are still in a, so doing some kind of migration to make sure that they balance. This is the result of adding more OST to the file system. And one of the main reasons that we have chosen IML is we do have a lot of HPC consultants, and they have no idea anything about file system. So, so this is actually great. It's like a good starting point for them to actually learn about Lasser. And that's it for me. We actually have Lasser user group meeting in Australia as well. So you mentioned that you want to go south. I don't know how much south you want to go. So Australia is a good country. So we struggle to get presenters as well. And if you are interested, come to us, and then we will talk about it.
As OpenSFS will do everything to support your LUG effort.
Yes. Yep. Yes. Yes.
You need to see.
Well, I can guarantee you can see kangaroos on the street. Thank you.